So this is HTML5 Canvas. I won't go into myself today. I'll do that a little tomorrow if you're interested in sort of the work that I'm doing. I'm really interested in just digging in to the HTML5 Canvas element. It is a HTML element for drawing pixel graphics. It's really for doing things that are quite difficult to do with HTML or SVG. Best analogy is between sort of Photoshop and Illustrator. Canvas is really the Photoshop, so really dealing with the pixels. Not exactly on the display. It's not quite at that hardware level, but and it's not GPU accelerated, but it is quite fast. If this was GPU accelerated, this machine should be able to render this Julia set very quickly in real time. As you can see, there's sort of a delay as it scans across and renders in these pixels at their full resolution. You might be interested in HTML Canvas because you would like to make these sort of interesting kind of interactive storytelling visualizations like the New York Times. So this one here is a real graphic from the New York Times. And if we just inspect here, I just want to show you a little bit of the structure of how these things go. There is actually an SVG underneath. And actually, if I just pick, let me just see if I can get rid of. So for instance, this element right here, if I delete this element, I've just taken away California's state. And on top of this SVG is a canvas. And this canvas element, if I get rid of this, removes all of these election trends from 2012, which is very nice. I use Canvas in my own work, which I'll talk a little bit more about tomorrow, for these sort of highly interactive data exploration tools. I like it because it's very easy to do little performance tricks with Canvas to keep everything very responsive, even if you have tens or 20 thousands of data points. It's very nice for building these sort of exploratory data tools. And in this case, this is also a mix of SVG for all of these ticks and axes. So if we zoom in on kind of this visualization, right in this little corner here is what we're going to do, right in there. And we zoom in a little bit. I think it may be hard to tell for kids nowadays because it's not so obvious, but these displays on our phones and our computers are made of pixels. And if we zoom in a little more, the pixels are made of subpixels. They're RGB pixels, and each of these are little lights that turn on and off and have different intensities that they can be. The electric light is pure information. It is just something that comes off of this screen and hits your eye and creates a reaction in your brain. So I like to think of working with Canvas as somehow really investigating this relationship between the pixels on the display and how they really interact in the surface of your eye. And once you're interacting, the information leaping off the display into the surface of your eye is immediately, in milliseconds, moving through your brain, crossing the optic chiasm, and sort of reverberating back and forth. So it is an interesting kind of medium to transmit information out of the computer into your mind. So I was looking for nice quotes about HTML5 Canvas. I found this one. I don't think it's quite right, so I made some modifications here. So we'll be using JavaScript to interact with this canvas. So JavaScript is the language we'll be using. And this talk will have a little bit of code, quite a bit of code, actually. This is all the boring stuff. Boring background. It's a pixel-based bitmap of RGBA image data. We're going to use some JavaScript methods on the canvas context. You can use JavaScript to load and parse, draw data, use some JavaScript data structures. Some of the applications of Canvas are generative art, data visualization, web-based games, and you can make drawing and image editing apps if you like. It has pretty broad browser support. It works quite well on mobile devices. So let's dig into it. How do we do it? We need a canvas element to draw on. This is the only HTML element we really need to get started. Just one HTML element. And then we are done. Well, OK, 2. We also need a script tag. And then within the script, this is the boilerplate to get started before we can get going here. We need to just grab the canvas element and then get its 2D context. There is a 3D context, WebGL. It is far more complicated to sort of get started with that one. There's significantly more boilerplate. So here's just a simple example of drawing some stuff with Canvas. So everything we do here are these methods or attributes on the Canvas context. It sort of stores an internal state about what styles it contains. So if we change the color of the Canvas context fill style to medium sea green, anything that's rendered after that will be this medium sea green color, which is this one over here. And anything you draw from then on and fill will take that color. It's a very imperative way of coding, so read it just kind of top down. We can make lines by beginning a path and then using the move to command to start our line, and then line 2, line 2, line 2, line 2. And then at the end, to stroke our line, it's just dot stroke. And that will take the stroke style. And the width of the line will be the line width. So just like fill style, we can set these attributes. We can close the path with close path. And we can draw shapes by drawing lines and then simply filling them in. So that's how you draw custom shapes. Circles are very much the same. Arc is similar to these move to and line to commands. It just creates an arc. So if you go from all the way to 0 to 2 pi, you get a full circle. When you're working with Canvas, it's really helpful to sort of use functions to pull interesting subroutines that make it a little easier to sort of express yourself as you're coding. So we could write that same program before with these 2 lines, putting our circles, if we have this function defined. So it's a function that takes an x, y radius and color, and then just immediately draws and fills that circle in. So that's just the very basics. You can actually do quite a lot with that. Just drawing rects and circles. Most of the rest of it is the JavaScript to really kind of create the data structure to create something interesting to draw. And I don't want to dig too deep in that JavaScript. I just want to show off interesting Canvas things. But something you may want to do with Canvas, because it is just sort of a perfect kind of technology for doing this, is simple animations. So I'm pulling in D3 here just for this one function, D3 timer. What D3 timer does is it just creates an animation loop. So this function in here will just be called over and over again. And the code we have in here should render a single frame of our animation. So what's happening on this guy on the left here is first we center the animation. So you can translate the context, which sort of moves your origin point where 0, 0 is, move it to the center of the canvas. And then here, just do a little bit of math, x and y. Math, cosine and sine sort of give you this circular pattern. They're a function of t. And then change its color a bit, also a function of t. So this is this argument that gets passed into D3 timer is the time elapsed since the beginning, since the animation started in milliseconds. And then draw a circle. If you don't want to sort of just be smudging along, you can always clear the rect every frame. And then you'll get just a circle moving around, changing colors, and not creating a worm behind it. But maybe you do want a worm, and that's when you can do a cool little trick to create particle trails. This is a little Boyd's animation in the background. And as you can see, they have these kind of little tails. They're little swirly tails behind them. And there's nothing really special going on there. It's just instead of clearing the canvas every time these Boyds move, it just sort of fades out what's already there. So it's kind of like, it's sort of like a pane of plastic is going over. It makes it sort of translucent, and it fades away the past. And just this fading away, you get this sort of interesting organic effect. So here's some more particle trails. And these are, let me just pull up some of these. They actually work even better in their live forms. All of these examples are sort of the same. Actually, let me just pull up the code here for one of them. What's happening here in this example is we're generating a 10,000 D3 range. Just generates an array with 10,000 elements. For each one of the elements, it just randomly creates a speed, an angle, and then a starting position. Here's just our draw dot. It's a very simple version of the circle function we had before, just for a smaller little dot. And then this is really the meat of the program right here. Every iteration, every frame of this animation, it draws a frame that's full black, but only 8% opacity. And then just covers the entire screen. So that's what's causing it to fade out. If we remove this line, right here, then it just all kind of fills in. And if we increase the opacity of this, it just sort of looks like little mosquitoes flying around. These other examples are all sort of the same sort of code underneath. This one just uses that HSL trick to sort of just give a different color to each one of these particles. And then these bottom two are using different compositing modes. So the interesting thing, let me just show you without the compositing mode. Let me close these. I think my computer is screaming at me. Compositing is the way that colors combine when two shapes are drawn on top of each other. So let me just pull up this example and remove the compositing. So by default, what happens is the new shape just gets drawn over the old shape. So you have circles just sort of occluding each other. It's frequently not what you want, especially in data visualization. It means that anytime you draw something, anything behind it is gone. It was sort of pointless to have rendered it even in the first place. But by using different composite modes, you can sort of create, there's also actually a global alpha. You could make things slightly transparent, but they're still being drawn over each other, and they're all quite faint. Everything is becoming fainter. So there are some disadvantages to using just regular transparency, although you can use it. By changing the composite operation to multiply, what happens is the colors actually combine in sort of a color theoretical way. Multiply causes them to sort of become darker, and screen will cause them to become lighter. Actually, here's a couple examples of, here's a better example showing moving through the color space of how these different composite operations change. These are GIFs, so they repeat in kind of a jagged way. So this one is the default up here. This is what it looks like. If you never specify the composite operation, things just get drawn over each other. And I find multiply works quite well on a light background, and screen is usually what you want on a dark background. Here's a simple data visualization. So a complex data visualization or just a full data visualization, most of the code, honestly, is just kind of loading the data, cleaning up the data, shaping the data, and then drawing ticks. There's so much code involved in drawing ticks and tooltips and things of that nature. The actual visualization itself of just turning data into a visual mark is usually quite compact. So here what's happening is we have a simple array of data. Just set the fill style. And then for each of these data elements, we call this drawbar function. And then it has some magic numbers that just specify that these bars should start here and sort of grow up. Normally, in a full visualization, we specify these magic numbers with a sort of quantitative scale. But in terms of rendering, it's really no different than what is happening here. So you can use Canvas for making maps, and you can also use SVG for making maps. And this is a map that I made. It's of infant mortality in the United States, and I'll just pull up both versions. You really can get them to look exactly the same. So for static graphics like this, SVG and Canvas really, let me just put them side by side. The one on the left is SVG, and the one on the right is Canvas, and they should be almost exactly the same. They will be a little different if you start zooming in. You'll notice that the SVG version, as you zoom in, retains its crispness. So vector graphics are sort of designed for that purpose. They're excellent, especially if you're going to print out a visualization, or if you're going to use it in different scales, and vector graphics is great for that. The other thing that it's great for is if you want sort of kind of a tooltip just on top of each one of these elements, it is actually a lot easier to do with SVG. You can attach event handlers just like in HTML, on mouse enter, on click, these sorts of things. With Canvas, the problem here is if we just inspect this element, it's in a frame, so it may be confusing my, just open it in its own window. There's really nothing there to grab onto. There's just this one canvas element. So each one of these marks in this visualization doesn't have its own element with its own event handlers. So I'll pull up a way to do it at the end if there's a little time. There is a color trick, which I can pull that up at the end. But how do you make this map in the first place? I think sort of making the static version, I think, is sort of the essence of visualization to begin with. Maps, the critical thing about geographic maps is they need a projection. In this case, it's using D3's Albers USA projection. And then D3, what it can do is it actually has, in its geopath, it can take your canvas context that you're rendering to, and it knows when you pass in geographic data, which is usually in the form of GeoJSON or TopoJSON, how to render out all that data, or at least how to create the path, just like we did earlier when we were drawing that M. So what it will do when you begin the path and then use, and here this path down here is referring to this D3 geopath, it will go and it do the move to and line to commands and draw out that geographic shape based on what it sees in the GeoJSON, or what you might have exported from your GIS application or downloaded as a shapefile and converted to GeoJSON. And then it's up to you, after it's gone through that path, how exactly you want to fill and stroke it. So in this case, we're applying a fill style, which uses, and here's a color scale, a threshold scale based on the infant mortality rate for each of these counties. And then the stroke is just sort of a white stroke to create some division between the counties. This is the example that we'll sort of pull up and play around with some coding. These are some science satellites, and this is kind of bringing together a couple different techniques we've just talked about. So here we're using animation again, so D3 timer. We're actually taking the time elapsed in this animation and actually running it at 151x speed by just creating a new date and multiplying by 150 and adding that to the current time. And then for each data element, which this is kind of pseudocode. There's actually quite a bit of code in this example, and I don't want to go through all of it, but this is the essence. For each data point, we're running a plot satellite function. And that function is it's a function of the orbital parameters of that data element and the time. It's the time you want to know where the satellite is in the future. And then you can use a library, satellite.js, to actually propagate out where that satellite will be and then get the ground position. And then that ground position is now in longitude, latitude coordinates, which you can pass into the geographic projection just like D3 had, and then draw the satellite. So here's a live version that you could click through. And I will put these slides on my blocks page, which is here. I'll put this tomorrow afternoon. The page that I was just trying to open, though, is this one. So this is the link of one to play with. And I will just open it up on my local machine so that I can mess around with it. So this is the actual code. It's significantly longer than the example I listed. Just because it's bringing in the data, setting up actually several canvases, setting up an actual projection and setting up a lot of margins. And I just don't think the margins and things are very fun. And I have this example here. So what can you do? So this is what we already have. We have these are actually not science satellites. These are CubeSats. So somewhere there is a flying laptop, I believe. These are the small satellites that there's a small form factor, and they can launch quite a few of them every time. And so it's popular for universities to have these CubeSats. I believe that's what these are. Oh no, these are science satellites, because this right here, this is the Hubble Space Telescope, HST. So I take that back. No, these are science satellites. So we have our animation going. So what are some things we can do when we're in full control of the map and everything happening on the screen? One of the things we can do is we can actually change how the projection is rotated. So this is something that you cannot do if you're pulling in SVG files that have kind of a map already rendered, or if you're using a Slippy map like Leaflet or something, where you have pan and zoom and it kind of renders all that out for you. It's pulling from a tile server, and those tiles are all pre-rendered. Usually it doesn't have the ability to change your projection, but here we can. So let's say we wanted to center this whole world on Malmo. We can do it like that by just putting in the longitude, latitude coordinates. And since we're already animating it anyways, let's say we want the whole world to revolve around Malmo. Why not? We can just change the projection's rotation, make it as well a function of time. And then all of a sudden we have something like this. So it's a little different way of thinking about things, I think, from normal web development. Normally when we're dealing with HTML and sometimes even SVG, it's really boxes within boxes. Everything is nested boxes on the page. And we're thinking about how to lay out these boxes in grids maybe, or maybe we want the boxes to stretch, but it's always boxes and boxes and boxes. So HTML Canvas obviously is just a different way to think. So I very much enjoy it for that. I think it's quick to get started and just to start making something interesting. There's some places to learn more here. Actually, I know there are probably a couple people in the room who are quite concerned about interaction with Canvas. Many people think that it's not possible to interact with the canvas, but it is. There are some little tricks. Nadia Bremer does a great job explaining some of these tricks here, and I'll just scroll down to quickly explain one. One way to do interactions with all of the elements that you've rendered is actually to render everything twice. So you render one, your normal visualization. Actually, I have an example where I do render it twice. Let me skip ahead here. So it's a little weird, but you actually use a second canvas, and it's actually use it like you would use a hash or a lookup or a map. So when a user is hovering over an element, hovering over your canvas, you actually go and use the getImageData function. And what getImageData can do is it can pull out the pixel information at any point in the canvas and give you the red, green, blue, and alpha values. And so what you actually do is you actually use this RGB value just as a key to look up your data. And you could store millions of data points that way. And the nice thing about it, if you're really serious about sort of performance in your interactive visualization, is that you could be rendering and interacting with millions of data points, but there are not millions of elements rendered on the screen. There are only two, well, there's actually only one element, one canvas element. And then this one is sort of hidden. And there's actually sort of quite a bit of performance savings by not actually rendering it on the page. So normally the user wouldn't see this rainbow mess. This is something that is just for you to use to support the interaction. There's actually a couple other techniques for interactions. You could also use quad trees or just kind of nearest neighbor search, just do a filter on the data points to find the nearest neighbors. D3's force-directed simulation actually has something like this built-in simulation.find to just find the nearest data point. So there's actually quite a few ways to sort of support interactions in that way. And that's it. So please go out and draw some recs. Thank you very much. I think there's not quite enough. He's talking about this. Is there an interactive version here? Tools.
This is 200 and something data points that are animated over time.
Oh, so some rules of thumb if you're trying to decide between SVG and Canvas. SVG works actually pretty nice up to about 500, maybe 1,000 sort of rendered elements on the display. So if you're just doing an animation with a couple hundred elements, SVG usually works quite nicely. It might slow down a little bit on phones. But once you get into several thousand, tens of thousands, Canvas is quite nice. And then if you're going up into 500,000, 1 million, oh, what is happening here? WebGL is actually quite performant for hundreds of thousands of data points. Computers are actually quite powerful. That's a kind of interesting thing nowadays. A lot of computers have, even phones have 3 gigs, 8 gigs of RAM or more. Well, phones usually don't have more than 8 gigs, but it's quite a lot of computing power. So a couple hundred elements really should be nothing for a modern computer. But that's really all about you want to do in SVG. So, any other questions or? Oh yeah.
Canvas automatically do colors. If you go and render something outside the viewing area, does it automatically know not to render?
I am not totally sure. You know what we might be able to do is, well, for one, I do know that your code, obviously, if you have any code running on those, so for instance, this one, all of these little mosquitoes leaving the display, I know for a fact that there is still some code and computation running, like this one right here. It's still, computing. It's still going up here, and I'm telling the canvas to try to render it, even though it's out here. I think that is not really as expensive as actually rendering it in the display. I think it does know to some extent that it's not in the visible area, but I'm not 100% sure about that. Yeah, that's what I would do, because obviously I have my own code running here. In the other examples, these are actually, all the other examples here are torus wrapped. So in this example for like this yellow that's coming off is actually going to, I'm not sure where it went, should have come from the top somewhere. Wait, is my torus wrapping actually working correctly? It's pink. I think so. I think this pink one is this one right here. Let me try to follow one more. All right, this blue one. Okay, there's 3 blue ones. Psh. Okay, yeah, 1, 2, 3 blue ones came on the top. Torus wrapping is really simple too. Let me just pull this up. If you're just making kind of random interactive stuff, torus wrapping is a really easy thing to add. It's right here. It's just if the x value is ever less than 0 or greater than the canvas width, you either set it to the canvas width or 0. So it just teleports to the other side. And then the same for y. And it's just a useful little trick for generative art. All right, anything else? Well, thank you very much. Well, we could, please talk to me after.